My name is Ewelina Bolcun-Filas, and I'm an assistant professor here at the JAX laboratory. I enjoy science because you can ask questions and then answer questions. And you're only limited by your imagination, what kind of questions you can ask. I love JAX because you can do a lot of mouse genetics, and in no place else you can do that. Colleagues that are here are also a great benefit because I have experienced colleagues. Everybody thinks and works in different way. So if I can't answer this question, I can have colleagues that will help me to do that. So I think the collaborative nature of science as well, that makes it very interesting. I think something that I'm really proud of is my recent work. I study genetic causes of infertility, and we have a mouse that has a mutation in one gene that is important for meiotic recombination, and those mice are infertile because they fail to repair meiotic double-strand breaks. I was interested what are the mechanisms that eliminate those abnormal oocytes, and I found out a gene that is responsible for that. When I deleted this gene, additionally deleted this gene in my mutant mouse, this mouse became fertile or didn't lose fertility. This is something spectacular that you can rescue infertility genetically. Women cancer patients that are exposed to radiation, in particular in their pelvic area, so very close to ovaries, they can lose oocytes. When exposed to radiation, this checkpoint will get activated, and activation of the checkpoint will lead to a certain response in the cell, and this response will lead to apoptosis if this damage is beyond repair. CHEK2 is a checkpoint protein that coordinates those responses. It can either push a cell towards repair or push the cell towards apoptosis. Now, when we use inhibitor to block CHEK2, all those oocytes that were exposed to radiation can survive because CHEK2 is inhibited and does not signal to those downstream effectors, and thus those oocytes remain alive. DNA damage is repaired, and oocytes are good to go. In a way, mouse experiments show us that we can prevent oocyte loss. So hopefully, if we can work on the system a little bit more, understand how this happens, maybe we can protect oocytes from those female cancer patients that are getting exposed to radiation, and this way protect their ovarian function. To any young girl now trying to think what to do, what to be in the future, I would recommend first find something that you really like, that you really enjoy. It may be science, it may be engineering, maybe music. I think that the important part is identifying this one thing that you are enjoying, because if you enjoy it, you'll be good at it. So once you identify that, and if it's science, don't think it's a bad career, it's a difficult career. If you like it, just go for it. I would never discourage them from being a scientist. It's a tough job, nobody denies that, but it's a very rewarding job.